Alright, Chris from UK. You told me I misrepresented the flat earth model. That's actually false. You said I marked it at Polaris is thousands of miles or trillions of miles away. That's actually obviously false. What I did was have an arbitrary point. You can see the entire base of my drawing was longer than the actual height of Polaris. That means Polaris is closer than the actual diameter of the Earth. Once again, only went out to 45 degrees. That's half of the Earth's diameter, so that's actually pretty close Polaris. That's actually, so my guess is it's probably about 4,000 or 5,000 miles high. So, but I can't make anything to scale because you guys give me no numbers to put to scale, because you guys know that if you guys actually gave a number, it's testable. That means I can prove you wrong. So what I did was arbitrary, and just arbitrary distance to angles, because distance doesn't matter to the angles. Then I measured just to make sure, see if the distance to the points matched, and they did not. All right, then it's like nope, you have to put the distance, mark the bottom of the distance, and you can show that they're going to be the same. So let's actually measure the distance. So we got Polaris, we got 0, this is 9 degrees, 10 centimeters off. We have measure 82.5 degrees with the difference of 7.5. Add another 10 centimeters, we have a distance of 73 degrees with a distance of 9.5. We have 30 degrees with a difference of 66.5 with a difference of 6.5. We have 40 centimeters with 59 degrees with a difference of 7.5. At 50 degrees, or 50 centimeters, we have 50 degrees with a difference of 9. Notice the pattern here, that the change in degrees does not match the change in distance at the same rate. It changes. Our latitude system is based on the fact that this change in distance will be directly proportional to the change in degrees. This change in distance will be the same, directly proportional to the change in degrees. So for about every degree of change is going to be about 100 kilometers degree distance. So 5 degrees of change will be 500 kilometers. It's a constant rate. Notice there's nothing constant about this on the floor. What's up with that? So if you say I'm wrong, don't just say, oh, you're wrong, you're doing it wrong. Prove it to me. Draw a diagram showing me how this change in distance is directly proportional to the change in degrees. It has to be consistent on every point. Every change in degree is supposed to be proportional to the change in distance linearly. So if you have 1 degree change for every 2 centimeters, it has to be 1 degree change for every 2 centimeters constant. That's impossible in a flat earth. But hey, prove me wrong.